We have got our Quiz 2 preview for our quadratic section. It's straight up solving by factoring, solving by square roots. Now, here's the one thing I'm going to stress now. I'll stress it a few times. I'll still have some of you that kind of space on me, but hopefully not too far. Okay? Solving. Okay? You are finding answers here. Don't just factor it and leave it alone. That'll lose you points, and then you'll come up and go on, smiling at me, and I'm like, no, that was just silly. Okay? Again, I even put it here. You are finding the x values, okay? Not just factoring. So when I'm doing these, because again, I'm going to have my handy-dandy help sheet available. So, factor out any common terms. Now, it doesn't mean every single one of these is going to have something in common I can take out. It has to be all of my terms on this side of the equals. So if I don't have that, okay, I don't have anything in common, I go, all right, this kind of looks like we're heading towards a diamond because there's no number in front of my x squared. So we start looking for our hints. Multiplies to a negative. It's one of each sign. Adds to a positive means the positive number is bigger, and that 4 represents how far apart my two numbers are. And this shouldn't be too tough, because most of you, when you think 21, are going to think the basic 7 and 3, which is what it would be. I just got to make sure I get my signs right. And we've talked before about how you can do a quick check with that. I can do my outer and my inner, and then say, hey, does 7x minus 3x equal 4x? In this case, it does. So I can be, all right, I did this right, but don't stop. Now that you're factored, make sure you take each of those quantities that has x, set them equal to 0, and then solve the little mini equations. Minus the 7 over. There's 1. Add the 3 over. There's my other, and I'm good. Okay, not bad, not bad. Then I get to number 2. And again, if I mentioned it before and you missed that, if your paper was not adjusted to a minus 20 here, please make that adjustment, because otherwise this is going to be kind of hard. So again, I look at my golden rule. Is anything in common with 2x squared, 18x, and 20? Hopefully the answer going on in your brain right now is yes. They are all divisible by 2, but it doesn't mean it disappears. That 2 is still part of things. It just means when I divide each of these by 2, that 2 is going to be sitting on the outside. So we'll still have equality with this. So 18 divided by 2 is 9. Negative 20 divided by 2 is negative 10. And now I'm going to factor what's left on the inside. So the 2 is still there. We're just not working with it right now. We're just working with this part. I got x and x. And again, I go looking for clues. This applies to a negative. Only one way to do that. I got to get one of each sign. Adds to a positive, which means the positive number is going to be bigger, but they're 9 apart. So again, think about that for a minute. And if you're visual, it won't take you long because there's only 2 options. Well, 2 and 5 isn't getting me to 9, so I know that's not it. So it's 1 and 10. The plus tells me the bigger number is positive. Okay, lots of little ways to get myself some help. So when I get to the solving part, okay, the 2 doesn't have an x with it, so I can't set 2 equal to 0. But the other ones I can. And yes, you still need to factor it correctly. Okay? When it says solve by factoring, it does not mean, oh, you mean I can just guess and check if I forget how to do the factoring on it and get the answer. No, you will not get credit because you're not following the directions. Okay, I got to see that you know how to factor. So I get that set, and I'm like, all right, this isn't bad so far. So let's see what else we got here. All right. Again, just keep running through the steps. Makes it so much easier. Anything they all have in common? Well, of course, I'm going to try 2. 2 goes into 2. 2 goes into 24. 13, I get a decimal. Okay. Can't do anything. Here, my guess and checkers, you'd go straight into guess and check mode with 2 sets of parentheses. My slide and dividers, this is the point we'd do our sliding. Our sliding makes this look like it's going to be a diamond problem, and that's how we're going to treat it. Now this one might have to take a little more thought. So I start to look at this one, and I'm like, all right, let's see. Multiplies to a negative, adds to a positive, so I know the positive number is going to be bigger, but the whole 2 sign thing means they're going to be 13 apart. So I could go to my handy dandy chart on the back of my help sheet. I could go to a calculator. I could use my brain for this. And I start writing down some of the things that I may think of when I'm doing these. So maybe I just start playing with the calculator and I get all these options written down. But again, what am I trying to find? Since they're opposite signs, I'm trying to find the ones that are 13 apart. So I kind of scan things over. 14, no. Oh, there we are. And again, even if it's just taking the calculator and dividing numbers in until you find some pairs and then one shows up, that's fine. It's not going to take you that long. You got time. So the bigger number's the positive. Don't set these equal to 0, though. We're still seeing that happening on some quizzes and even homework at times. Remember, if you slide this down, if you multiply it down, now I've got to undo that. And so the opposite of multiplying is to divide. If it goes in nice, 16 divided by 2 is 8. That's good. If it doesn't go in nice, you punch 3 divided by 2 in your calculator, you get 1.5. We're not going to use 1.5. Okay? I hit math, enter, enter. It comes back 3 halves. I'm like, okay. So then I'm going to take that denominator, the number on the bottom, and slide it back to the front. And those 2 things now become the things I need to factor. And again, if you ever want to do a quick kind of double check, take your first terms, in this case the 2x and the x, and times them together. If you get the first term up here, you're probably on the right track. So minus my 8. Here, a little more complicated because my x isn't going to be alone even after I add the 3. And I got to finish. So here, divide both sides by 2 because we've got the multiply working. And here, 3 halves is fine, 1.5 is fine. But you've got to get the factoring part right, okay, to get to here. And we've talked about this before. I have people ask all the time. Well, technically, Harty, I could get to the answers at this step. Because this is just plus 8, and I switch the sign, and this is negative 3 halves, and I just switch the sign. That's true, but on the quiz, I want it factored correctly as well, because it says solve by factoring. That's not factored correctly. Okay, I'm not done yet. Just putting that out there. All right. Number 4. Okay, I want participation this time. Factor out any common terms. 3x squared and minus 21x. 3x. Okay, got to get it all. So sometimes we may have everything working. Okay, I've already got the 3. I've got 1x, but I need 2, so I need 1 more. Here I've already got the x, but negative 21 divided by 3 is negative 7. Here's where this one's a little different. Before, up here on number 2, when I pulled out the 2, I didn't do anything with it. It didn't have an x attached to it. But now it's a little different in number 4 because it does have an x. Anything with an x can be used to find an answer. So I can set 3x equal to 0, along with my x minus 7. Here I just divide by 3. 0 is a legitimate answer. Here I'd add my 7. I get my 2 solutions. So nothing too bad. You're like, whew, factoring. Ugh. Again, the more you get practice at it, the more it just snaps, and it makes things so much easier on everything else. All right. You know what's coming. Here I come. Anything in common with 12x squared, 26x, and 10? Even if it's little. Oh, I heard it. 2. Okay, so just because it's not the number in front doesn't mean there isn't going to be something. So here, if I get that 2 divided through, okay, there's some good news and some bad news for this. Thank you. So the bad news here is, it still looks like I'm going to have to slide and divide or guess and check. The good news is the numbers are at least a little bit smaller, so now I'm not going to be looking at triple-digit numbers that I'm having to work with. So for now, the 2 is kind of off to the side. I'm going to be dealing with this part. I don't know why I started making a parenthesis already. Now, if some of you are guessing checkers, that would be a good reason for you to have that. So I've got x squared plus 13x minus 5. And then just kind of, whoops, minus 5, Harty? No. Oh, these things happen sometimes to all of us. Keep my 2. All right, now we're making some progress. So my 6 slid down to the end. 6 times 5 is where the 30 is coming from. And I worked this diamond problem out. All right, let's see. What do we know? What do we know? X and x. Multiplies to a negative. That seems to be kind of a common theme here. Plus and minus. All right. Bigger number is going to be positive. So 30. So I'm like 5 and 6. No. 10 and 3. 10 and 3. Now, is it though? Because remember, when the signs are different, it means they're this far apart. Ooh, that was kind of tricky. Because 10 and 3 add up to 13, but they're not 13 apart. Oh, I got to keep going. 15 and 2, they're 13 apart. Nicely played. Okay, so it's those little things I've got to watch for. So since that's plus, that's where my 15 goes. And now we just had to deal with that, and now I still have to sit here and go, hang on. Remember, it's a slide and divide. I multiplied by the 6. Now I've got to divide by the 6. Ooh, all the pitfalls and holes that can be in this one. So here's a new issue that we've had. Another reason we're doing this one is so we can avoid it when it matters. This is what I was talking about earlier with making sure when you go to check. So you're like, all right, let's see here. 15 divided by 6. Okay, I got a decimal. I know I can't do that. Math, enter, enter. It reduces, okay, to 5 over 2. Here, don't let your eyes fool you. That's not 6 divided by 2. This isn't 3. It's 2 divided by 6. We don't do decimals. Math, enter, enter. 1/3. So now is the time I get to slide these buggers back. And it's good for it because I'm starting to run out of room here. Okay, denominator back to the front. And when I talked earlier about doing a quick check, this is one of the type problems I was talking about. Because I look and I go, okay, now if I take my first terms and I multiply them together, 2x times 3x would be 6x squared times 2 is 12x squared. Now I'm feeling pretty confident that I've done this right. If I wouldn't have reduced it before, that number would have been really big and I'd have had a problem. So here, 2x plus 5 equals 0. And again, take your time, minus your 5. And then divide by whatever's with x. Divide by 2. Again, when we get to answers, I don't mind a decimal. Okay? But before then, we shouldn't be seeing any. And then same here, my 3x minus 1. It's just about patience and practice. If we got those two p's, we should find some success here. But this time, the 2 doesn't get set equal to 0. Why? It doesn't have an x. Only stuff with x's gets to get set equal to 0. Then we're set with that. Like, all right. Oh, one more factoring one to survive. Thank goodness. All right. Participation. Here we go again. 4x cubed, 8x squared, 12x. What do they have in common? 4x. Don't get freaked out at the fact that you're seeing x cubed. Don't worry, I'm not making you factor x cubed at this point. It probably means that there's an x to be taken out. So here, 4 divided by 4 would be 1. You can put the 1 if you want to. I got 1x. I need to get to 3. So I need 2 more. Because 1 plus 2 is 3, my exponent rules. Negative 8 divided by 4 would be negative 2. I got 1x. I need to get to 2. I need 1 more. And then negative 12 divided by 4 is negative 3. I already got 1x. I don't need any more. So it looks like inside my parentheses, we're dealing with a diamond problem. So I'm going to be able to factor right away. Multiply to a negative 3. Add to a negative 2. So really all I got to decide is, I know it's 3 and 1. Where's the 3 go? Where's the 1 go? Well, that tells me that the bigger number, the 3, is going to be negative. And my only other real caution here now is remembering, this time my common factor has an x. When my common factor has an x, that can be set equal to 0. I don't want to forget about it. So this time I have not 1, not 2, but 3 answers. Because we've talked before about my degree, my biggest exponent always going to tell me how many answers I got. So if it's squared, I'm going to have 2. If it's cubed, like it is in this case, I'm going to have 3. And I can get that set. So not bad. Not bad. But again, you've got to get the practice in, and we've had plenty of chance here too. So if you're still kind of working on that, maybe knocking out some of the homework problems would be a good idea. So as we flip to the back, our other part of what we did last week, solve by taking square roots. Exact answers, not decimals. In other words, we got to break down radicals if we can. Remember how many answers quadratics have? 2. Mainly dealing with plus minus is the thing I've got to remember. So we talked a lot about, when you're dealing with these, we want to isolate our x squared term. So here I do my opposite of plus in 20, minus it. Goal is still the same. Now that my x squared term is alone, I need to get x squared alone. What am I doing to it? I'm multiplying it by 3. And this is a conversation you need to be having in your head with yourself. Again, in your head, not out loud during the quiz. And once that squared is isolated, we're ready to do our inverse, our square root. This is the point. Once I get to doing that square root, where plus minus comes out. And the square root of 16 is 4. There's my 2 answers. And we've talked before also about how the help sheet can help you on this too. It's not just for your factoring. And we've also spoken how I said it was okay if you actually wanted to write what the square root of each of these numbers were above your squares, that I didn't have a problem with that. So here you'd be like, oh, the square root is 16. Oh, it's 4. Oh, okay, I got the answer. I mean, I can do it on the calculator, but if I want that backup, I can have it. And so as I do these, my x squared term's already alone. I want to get x squared alone. What am I doing to it? I'm multiplying by 8. What's the opposite? Dividing by 8. Okay. But this time, I notice 20 isn't on my perfect square list. Or I punch it in the calculator, I get a decimal. We're not doing decimals. So now the game plan becomes, is there a way to break the 20 down? So I pull my list back out and I go, okay, do any of these perfect square numbers evenly divide into 20? And again, the bigger the better. Well, I noticed 16 doesn't, 9 doesn't. Ooh, wait, 4 does. So 4 times 5 is 20. And I'm taking the square roots of those still. So what will happen is 1 will break down, but again, 1 has to be a perfect square. So for instance here, 2 and 10 wouldn't help me. So now I've got 2, because that got out of radical jail for being perfect. 5, still acting irrationally. Oh, even caught the math joke that time. Well played. Well played. Okay. And we're set. Now, the only thing that can kind of get thrown into these as a twist, besides having to break down the radical, is a problem like number 9 or number 12. This is the one exception to the square root being your last step. And we've talked about this a bit too. Here, I still want to work on isolating that term, so my parentheses with the x stuck in there. So I'm going to divide by 3 because I'm multiplying it. I do not want to distribute. Oh, please do not distribute. So here's where it's different. I can't plus 2 right now. Why not? It's stuck in the parentheses. So my initial job here has got to be now to get rid of the parentheses is my next step. And what's stopping me? The squared. How do I undo squared? Square root. So it's a little earlier on these. So that gets rid of my parentheses. There's my plus minus. Got lucky this time. Okay, square root of 9. It's a perfect square. It's 3. And so now, since I'm trying to get x by itself, and I'm minusing 2 from it, I'm going to plus 2. But here's again where we got to be careful. I know how some of you are thinking on this. I've seen some of you do this. This is not plus or minus 5 now. Okay? Whatever you add or subtract goes at the start. Then your plus minus in the number. And here's why I have to do it that way. Because now, since there's no radicals left, I can continue with this. And I can figure out what 2 plus 3 and what 2 minus 3 equal. So I do get the 5 that I thought of before, but the other answer is not going to be negative 5. But the only time I have to take it that extra step is when, this isn't a radical. If it was still a square root or a radical, I'd be done at that point. And we'll see that on another one here. So I get those answers. And then it goes back to normal. You're like, all right, ooh, fraction in front. How do I deal with the fraction in front? We're going to multiply by the reciprocal. We don't want to divide by the 1/3 because some of you are going to try and turn that into something that's not. 48 times 3 is 144. X squared term by itself, awesome. Square root it. Get some plus minus going. And 144 is a perfect square. If you're not sure, you type it in your calculator and you're like, oh, it's just 12. Okay. Bless you. Here's the issue that I also want to mention here. Sometimes I'll have people get this and they'll get the 12 and they want to keep the square root on it and break it down more. There's no radical left here once I take the square root of 144. If there's still a radical, I got to watch, but there's not, so I can't. Down the home stretch we come. X squared term alone first. Add the 8. still attempting to get x squared by itself. Opposite of multiply by 4. And now I got to think again for a minute. Do my square root. Get my plus minus. But can I do something with 24? So I start looking. And I go, all right, 24 is not a perfect square. So I start punching things into my calculator maybe. I punch in 24 divided by 16. I get a decimal. Punch in 24 divided by 9. I get a decimal. I punch in 24 divided by 4 and I get 6. I get a whole number. So that tells me I can break this down. Again, one of the numbers, if you're going to break it down, has to be on this list. Okay, the one that's pre-printed on here. If the numbers you get that multiply are not on the list, you can't do anything. So one of the numbers will break down. One of the numbers won't. And I'm done. Okay, but I need to get to that extra step. So let's say you left it as plus minus square root of 24. You're going to lose 1 out of the maybe 3 to 4 points this would be. And we got one last one. Again, I notice the x is stuck in parentheses. I cannot minus the 5 right away. I got to get rid of the squared first. So I do. But I look at 45. I go, 45. Get my list back out. Try 36, I get a decimal. Try 25, decimal, decimal, ooh. When I get to 9, though, that 9 works. 9 times 5 is 45, and 9 is a perfect square. So once I get there, and here is going to again come our moment of truth. Because I'm like, okay, I know I need to minus 5. We need to remember back to how number 9 kind of played out. So I get to this step. And here's where people take it a step too far and end up getting it wrong. That actually is my final answer. And what I'll have people do is they'll want to keep going with this. So what I'll see people do here is they'll be like, negative 5 plus 3 square root of 5, negative 5 minus 3 square root of 5. And even that would be okay, but then they're like, no, I can add these together and I can do this, and I can do this. No, you can't. Okay? Here's what I want you to think of when you think of a radical like that. Would you, if I change this up slightly, if I told you negative 5 plus 3x, negative 5 minus 3x, would you tell me it was negative 2x and negative 8x? I hope not. They're not like terms. Same thing here. This has a radical. This doesn't. I can't put them together. It's not like up here where there was no radicals. Okay? So don't get into all this crazy business. Okay? That is your answer. Quiz tomorrow, shockingly, 12 questions. Okay? Breakdown will be the same. If you've practiced, you're going to nail this, and you're going to be in really good shape. If you didn't, some of you are going to keep digging a hole, which is going to be a problem at this point. So do not be digging a hole. Let's fill in the hole. That's good. And bury the badness. So